Hello guys, welcome back. In this video, let's create a fully local retrieval augmented generation RAG application using the DeepSeek, and that will be using from the Ollama, right? So this is the architecture that we will be following. On the top, we will be using Docling, which is one of the Python package that we can use in order to extract the information from the PDF, and that is really good package. After we use Docling, the PDF will be extracted pages from the PDF. We'll split that into different chunks. In the embedding model, we will be using the Huggingface embeddings. Once we have the embeddings, we'll store that into a knowledge base, and in this case I will be using Qdrant with Docker. So we have the Qdrant running locally in our machine, and then when we ask the question, for example here we use the same embedding models, the embedding is done, the semantic sorts is done from the knowledge base, and we get the results out of it, and that result is passed into the DeepSeek. Then we'll get the answer based on the question we ask and the context out of it. So this looks complicated, but at the end what we will be seeing is something like this. For the UI part, I'm using the Chainlit in order to orchestrate all the different things, and LangChain is used under the hood. You can see I'm asking a question here and it does different steps. There is the thinking part, which is good, the DeepSeek model. So it first goes through all the informations before it provides us the answer, and at the end you can see here is the thinking process is done, then it provides us the answer. This will be an end-to-end implementation of RAG, fully local, using advanced tools, so that you can take benefit of the tools available without connecting it via any APIs. Let's get started. Okay, I have already uploaded the code into the GitHub, so you can go inside YouTube. I have provided the steps how you can follow along with me in the video. Please clone this repository. I have already cloned here. You can see this is the Chainlit and all these informations are here, and I'm already running this in my VS Code. If I go here, this is the same instructions and I have all the code in the VS Code, right? So first thing first, in order to use this, I'm trying to first ingest the documents, so that whenever you run the application, you don't need to upload the PDF, and all the steps does not need to be done there. Once you ingest it, you can ask the questions out of it. But before that, let me go to the readme, because there is some initial steps that you need to do. Okay, this is the normal cloning process. You can use any other Python package manager, but I'm using UV to handle the virtual environments and so on. If you are new to this, you can refer to these videos. But we need to install Docker locally. If you don't have Docker, you need to install Docker. I have already installed Docker, and here is the link. First, we need to run the Qdrant. Here you can see I'm already running this Qdrant with this command. As you can see here, this is the same command which I have provided here. Please run that and you will be up with the Docker, right? And then down here I'm saying Qdrant URL localhost, because when you run the Qdrant locally, it will provide us the localhost. As I have already done this, rename.env.example to env, so I have already renamed this, and inside this I have the same URL localhost. Once that is done, we are good to go with this part. And now let's go and see the ingesting part, then we run the application with the Chainlit. First thing first, with the ingest, by the way, I'm not going through other aspects of Qdrant, UV, Docling and so on, because I have already created different videos related to those. If you want more information, you can go there, and also I will provide the link in the description of the video. Some of the important links will be here. For example, if you want to create more advanced functionalities out of what I am showing here, you can refer to the official document. So yeah, first thing first, let's go with the ingesting part. So here, these are the normal importing things that I'm doing here from LangChain. We need to have this markdown splitter, and Huggingface, we have the Huggingface embeddings. From the Qdrant, we have the Qdrant Vectorstore and so on, right? URL, and you can see this is what it is loading the environment variables from the .env. I'm just having one now, but if you have many, it's a good practice of having that into the .env, and you can just use that into your Python code. In this case, I'm using the embed model ID as sentence transformer, and this is the model that I'm using. Export type and the file path, I'm taking the example of DeepSeek R1 PDF, the same model. This is what I will be providing as the source of document for us to do the RAG applications, and we'll be asking questions out of it later. So now I'll go back to ingest. I'll make this a little bit bigger. So yeah, let's see what are the steps we need to do to create the vector database. There is a function called create vector database. Inside that, as you can see here, I'm using the Docling loader. Inside that, you need to pass the file, in this case our DeepSeek R1 PDF, export type, and I'm passing the export type as doc chunks. Then you need to pass the chunker, hybrid chunker, and I'm passing the tokenizer as embed model ID. So this is what the Docling is good into it. So you can pass all the informations already inside the Docling loader, so it does thing for you. It's just a simple thing. Docling goes to load, right? And this is the second part I'm saying here, determining the sprints. This is directly from the documentations. If the export type is doc.chunks equals to Docling documents, right? But if the export type is markdown, and we mention that, okay, header to split on heading 1, heading 2, heading 3, this is done here. Else you can see if this is not there, just raise the error. So unexpected error type is found. So this is the good idea of providing the informations in it. After that, I'm saving the documents that I get from the Docling so that I can view what is there. This is the good idea also for you to see, okay, what you provided the PDF and it did the extraction of the documents from the PDF, and you want to know what it did with this code. It will be saving as a output Docling. I already have it here, but I will run the code first and then point you here. For now, I will just delete this thing because I don't need it. I will create it later, so that is deleted. And now we initialize the embeddings. For the embeddings, as I said you before, I'm using the Huggingface embeddings and embedding model. After that is the next step. We need to create the vector database. For the vector database, and we said from documents, and documents we pass the splits, as you can see here, the splits, and we have the embeddings which pass the embeddings here. URL is Qdrant URL because we are listening in our localhost. Collects. So once we pass all these different things, our first part of the diagram that I showed you, this first part is completed because we have the Docling to read the PDF, extract the contents. We have the Huggingface embeddings to do the embedding part, and we are storing that into the Qdrant Vectorstore. If we split this in one file, then later we can just go into this lower half part, so we don't need to do the ingesting all the time. What I want to do is I want to run the file, or maybe it's easier if I run the thing already in the VS Code itself. I will open a terminal here. You can see what I'm doing. So I'm inside the Chainlit here. So here I can say UV, because I'm using the UV run ingest.py, right? Ingesting. Now just remember, we have the data. If I run this now, it will do the ingestion part. By the way, I have already done the UV sync, so all the packages are being installed for me already. This is the step in the documentation. As you can see here, once you go inside the CD Chainlit, just run the UV sync. It will install all the necessary packages for you, so you don't need to do pip install and all the different things. Here it says token indices sequence length is this. This is the error that we get from Docling, so we don't need to worry about this. And it says here vector DB created successfully. So now you can see here there is this output Docling. If I click this one, so this is the markdown format of our PDF, which is this one, right? So everything is being now converted from PDF to the markdown. We can ask the questions from this markdown now. So this is done here. Now the second file which runs the application. So here we have the same embedding models needs to be put in all the importing things. One thing to point out here is I'm using the Ollama LLM from LangChain. You need to have the Ollama being installed. In order to make sure that you have Ollama installed, you need to see something like this. And if you do Ollama list, you will see all the models. You need to download the model from the Ollama. Just go to Ollama's website. I just want to show you this because if you are new, then you might be confused. So you need to go to this Ollama's website, download Ollama first if you don't have, because when you run it locally, you need to install many things locally in order for the RAG application to work. Because if you just do a API call to some of the LLMs, you don't need to set up all the different things. One thing to point out is also that how well the LLM will perform will be also dependent on your local machine. How big or how powerful is your machine, right? From here you can just go here and you can just choose any of the models you want. You can see the size of the model and so on, right? For running the smallest model, you need to have some power, let's say, in a way. If I go to GitHub, I has mentioned also this in their GitHub. If I scroll little bit down here, so you can see here you should have at least 8 GB of RAM available to run the 7B models. So if you don't have this 8 GB of RAM in your machine, or you need to have a little bit more also, because other things will be also running in your computer, so it also needs some power there. Just keep this in mind which model you want to use, because when you see the documentations or videos like this, you see that it's running so smoothly in the machine presenting this. For example, for me, I'm using the 36 GB of RAM and the response time is quite fast. But for you, you need to have some level of power for the applications to run there. Once the Ollama is ready, it's okay. You need to have the model downloaded in your machine, right? Then same thing here. I'm passing the Qdrant URL because we need to now read the collection being created. And this is the embed model here. This is the custom prompt. You can just change whatever you want here. And then I'm using the LLM. You can see here LLM, Ollama LLM, and I'm using the model which I downloaded in my local machine, DeepSeek R1 latest. So after that, I'm just running this formatting, and now comes the Chainlit part. There was no Chainlit involved here. We just have the template, answer the following questions. Okay, I have this in 2 places. I don't even need to, I was testing with different prompts here and there. I can delete this one, and now we have the template already here. And this is the prompt, chat prompt template, and we pass the template here. So this is the part where you can make or have your own template. And here this is the formatting things. Okay, I have in 2 places because now I was before testing outside the functions, and now I have inside the functions, so that's good. And now comes the embedding part. You need to use the same embedding here. And the vector store, we created the vector store before, but now we are going to retrieve from the existing collection, so we need to have the same embedding, same collection name, and the Qdrant URL. And then there is the retriever called vector stored as retriever. If I go back to the diagram, this is exactly what is going here. You will have the question that needs to go to the embeddings, and then that needs to be done with the semantic sorts and going into the knowledge base, and that is the Qdrant in our case. Now we need to go to the Qdrant's database, right? Here you can see there is the Docker, and it is listening in port 6333. So if I click this, it will take me here. But if I then just go dashboard, so here you can see there is the rag here, and all the splits that we did is being stored here. And you can see here there is all the metadata also being stored inside it, so you can get okay from where it is taking from. So you can see here source is data DeepSeek R1, and this is the schema I also mentioned here. This is the version 1, table 2 informations, parent, and label is table, and so on, because everything that is coming as a metadata is coming from the Docling, so we don't need to do anything. So when we search the question, it is going to take these informations into account and provide us the answer. So I hope this is clear for you. And now if I go back to our code here, and this is the runnable now from the LangChain, right? So here we have the context, retrieval, format, docs, question is runnable pass through. We have the prompt right here, and then we pass the LLM, which was here, and then we pass the structure output parser, and then we use this as a runnable. So this is the code taken from documentation of the Chainlit and LangChain, both of these. And now this comes on message. So here there is two parts: on start chat and on message. Now on message is when you ask the question. We use the user session get runnable, right? Message context, and then we pass the context. Here you can see this is the class, and all these informations here you can see there is the init callback handler for handling the retrieval and LLM processes. So I have taken this directly from this documentation from the channel. It is getting the on retrieval end, source page pair, and on LLM end, and so on, right? I don't need to go through each and every step. And once this is done, then we will get the answer out of it. This is what the Chainlit documentation is from. Now what we can do is we can just go to the terminal. It's here. I will run now uv run chainlit, and this is the file rag chainlit deepseek.py, and dash w is we can see all the debug things here, but you don't need to do this also, because if you do dash w, if there was some modifications that you need to do, it will refresh automatically. But let's do dash w also, no problem. Now we will have the UI. This is the UI that is popping up here. So now you can ask questions from that particular PDF. We can go to the PDF. So you can see under the hood, it is using the PyTorch device MPS, load pre-trained sentence transformer, and it is taking the collection from localhost 6333 collection rack. These are the things going under the hood in the terminal. I will just bring this down, and from here you can ask the questions whatever you want. Let's see some questions. Maybe let's ask this: can you provide me about the training template? So I will go back here and I will ask, can you provide me some info about training template? Now this is the good part of Chainlit also. Here you can see it is saying use runnable pass-through, use vector store retriever. So if I go inside here, you can see it asked this question and it went through this and it gets the answer already from here. And this is the formatting docs, and now it is using Ollama. Now comes the DeepSeek part. So it is doing the thinking now. So I need to figure out how to answer about the training template in their context. This. And it already sees here the user has given a section title 2.2.3 training template, because now this is for the Ollama LLM, right? This is the retrieval part which already retrieved the informations, and here we have 2.2.3 training template that is being extracted already, right? Just to show you the diagram so you understand, we asked the question, it went, so this is the question. Now it does the embedding API, Huggingface embeddings. Embedding is done. We did the semantic search with the base on the question we asked, and then here is the vector database. We use the Qdrant, and now we have the answer out of it, and that is being passed for the LLM. In our case, LLM is the DeepSeek. So you can see all these things was being passed, and then the LLM was thinking because we passed something for it to get the answer. That is the part where it did some thinking. Let me see which one was it. Yeah, here you can see it was thinking here. The user gave this, which explains they desired a template for running this template instruct this, template structure, avoiding biases, and so on. It went through all the different things. Now the user is asking for information about this. Now it finishes thinking here, and now it provides the answer. The training template is designed to guide the training process of DeepSeek R10 by providing a structured approach. Key aspects of reasoning process first is straightforward structure. So if we go to this here, so here to train this template DeepSeek the produce a reasoning task followed by the final answer. We intentionally use this, and so on. So it gets the answer from there. We intentionally limit our constraints to this structure format, avoiding any specific things. Exactly, it even formats in a two different headings, right? So here is a reasoning model first. The model is structured to generate detailed reasoning. It provides us the straightforward structure and so on. So you get the answer how it reasons first and provides you the answer, and so on. And it now let's ask some question from table informations, right? Here what we can do is, this is the performance by DeepSeek R10. We can ask the questions from this particular table also, if it can provide us or not. Let me ask the math 500 for OpenAI 01. Let's see what I can do. I can ask the question, can you provide me the math, okay, no, can you provide me the math 500 score of OpenAI 01 mini compared to DeepSeek 10. This is the question. Now it goes through all the step again. This is the good part here. And if we go here, it retrieves some information. Okay, all right, so I need to figure out the math 500 score of OpenAI 01 mini and DeepSeek R10, right? Before going into the LLM, one thing that you need to be thinking is, LLM just provides us the answer in drag, the context that is taking from, right? Here it says the OpenAI 01 mini model achieved a pass 1 score of 90 in the math. Is it a 90? Okay, it's actually correct. So here it says math 590, right? It went through this math 590 and 95.9, so it is 95.9 by DeepSeek R10. So it is going to the right document. So you can see that it relies on the retrieved informations from here. This is the one surpassing this in math 500, so it gets the informations from there, and then based on that it provides the answer. The good part, you can see here how it does the reasoning. This is the main part about the RAG with DeepSeek. You say, all right, I need to figure out this. Let's break this down step by step. First, I will look through the given informations to identify relevant data points. The user is asked specifically about the math 500 score of both models, so it knows that it needs to go through both of that. Looking at the first section under summary of evaluation results, it mentions several benchmarks. On MMLU, these things, it provides this one. Then in another part, it talks about Math 500 DeepSeek R1 attains an impressive score of this. From this, I can gather that for the Math 500 benchmarks, DeepSeek R1 has 97.3 and then OpenAI has 97.3. Also has the similar score of 97.3. But wait, the user is asking about OpenAI 0. Here you can see it went through 12, 17. In the same section under summary of evaluations, there is another table comparing the models. So now it went to the table 2, right? And now if I go back, I think it's table 2. You can see here. That is the table 2. And here it says in table 2 performance for each model, right? For OpenAI this, it has this one, OpenAI DeepSeek R10. Putting this together, OpenAI 01 mini math this and this. So I should make sure there are no other conflicting data points in table 2 that might affect these scores. Scanning through all the entries for math 500 across different models, only this and this are respectively. No other numbers pop up for the benchmark. Therefore, I can confidently state the scores as per the given data. You can see how it does the thinking based on how we think, right? This is the powerful thing people are talking about, the reasoning capability of DeepSeek R1. Getting the data is one part, right? Which vector data you have to use, which embedding models you want to use, and passing that information into the LLM, and LLM synthesizing the answer based on that is another level, right? So yeah, you can see this is what it is shown. Now you can just try it yourself. That's all for this video. Thank you for watching and see you in the next one.